Okay, we didn't really work with exponential or logarithmic functions, and up on the board, one of the far right uh, graphs, or the very far right graph, is exponential and log parent graphs. And e to the x and 2 to the x are very, very similar graphs, just different bases. What they both have in common is when x is equal to 0, so when it's a 0 exponent, any non-zero number to the 0 exponent is equal to 1. So notice the parent graph for either one of those, when x is 0, it's going to touch the y-axis as 1. In this one, the parent graph, instead of being e, y is equal to 2 to the x would be the parent graph. And I went ahead and graphed it here. When you put, so I have it mapped out here. If we put in x values, whoops, I don't know what happened there. Oh, yes I do. Sorry about that. So when you put in 0, you're at 1. When you put in 1, you're up here at 2. When you put in 2, you're up here at 4. When you put in 3, you're up here at 8. When you put in 4, you get the idea, and then boom, you get the graph. When you put in -1, should be right there at 1/2, and then goes further. Well, we have this new graph. Well, you have to be really careful. Remember, order of operations, you have to apply exponents and then multiply. So if you're not sure, just by looking at how to solve that or how to graph it, go ahead and do a table of values. And I'm going to go ahead and put these x values right here. So when you put 0 inside here, 3 to the 0 is 1, 1 times 2 is 2. So I'm going to change the color. So when we put in 0, I'm going to put a 2 right there. When you put 1 in, 3 to the first is 3, 2 times 3 is 6. When we put a 1, we're up here at 6. When you put 2 in, 3 squared is 9, 2 times 9 is 18. So we're already, look at how rapidly that's going. When you put -1 in, I should have done that one. You put -1 in, that would be 2 times 1 over 3 to the first, which is 1/3, which is 2/3. So it's a little bit taller than that. And then boom, look at this graph. This would be, I'm not going to be able to draw that very straight. I shouldn't say straight since it's a curved line. I should have said smoothly. All right, so that's what this new graph looks like. And be careful here. I'm going to go ahead and do this. I'm going to put new x value. So I'm going to put, I'll put -1, 0, 1, 2, 3. All right. Well, we know that when we put, well, I'm going to put 0 in first. 2 to the 0 is 1. 1/3 times 1 is 1/3. So now look at this graph. Instead of being up here at 1, we're down at 1/3. So when we put 0 in, we're at 1/3. What happens when we put -1 in? Well, 2 to the -1 is the same thing as saying 1 over 2 to the first, which is 1/2. Well, 1/3 times 1/2 is 1/6. I'm going to have to make this thinner. 1/6 at -1 is really going to be, 1/3 is closer to here. All right, let's put 1 in. 2 to the first is 2. 1/3 times 2 is 2/3. So when we put 1, we're up here at 2/3. When we put 2 in, 2 squared is 4. 4 times 1/3 is 4/3, which is 1 1/3, which is about there. 3, 2 cubed is 8. 8 times 1/3 is 8/3, which is just under 3. So it's 2 2/3. So notice this is growing at a much slower rate. There. All right, and the next video will be on, let's see. Nope, I'm going to keep going because I can do these next 2 videos pretty quickly. All right, if you look at the parent graph, or if you type into Desmos log of x or ln of x, you'll see the parent graphs that I have up here on the screen. It's hard to see it, but this gray area, that is the log, or essentially the natural log graph. They vary a little bit, but not too much. And then look at, you're going to do the shifts just like we were doing before. This tells you how far to go up or down, and you do exactly what it says. So subtract 4, you're going to take, I always look at where it hits an integer point, and I'm going to go down 1, 2, 3, 4. And the opposite of positive 5 is negative 5. So I'm going to take this and go 1, 2, 3, 4, 5. So notice at this right here, the integer just to the left of that is 0, and it gets really, really close to 0. So this is going to get really close to negative 5, whoops, but never touch it. So this is going to go down infinitely, and then this is going to head off this way. All right, same with over here. Now that was the natural log function. This is the log function. Their graphs differ a little bit, but essentially the same idea. Again, we're going to take this, did I leave it? No. We're going to take this point from the parent graph. We're going to move that down 1. The opposite of negative 1 on the inside tells you to go left or right. This tells you to go up or down. But on the inside, you do the opposite. Remember, you do the opposite. So the opposite of negative 1 is positive 1. So we're going to move that here. And again, it's going to get really close. I wish I was great at drawing smooth lines. So, just like that. All right, that's it.